All right, in this lesson, we are going to basically do the opposite of implicit differentiation. So, implicit just means that we have x and y on the same side in our equation. So, just to review how that works, when I take the derivative of x squared, it's 2x. But when I take the derivative of y squared, it's 2y times the derivative of y, which is dy dx. Derivative of 9 is 0. And then we solve for dy dx, so I would subtract 2x from both sides and then divide by 2y. So I'm going to have negative 2x, but then when I divide by 2y, those 2's are going to cancel out. So we'd get dy dx equals negative x over y. So essentially what we're going to do is we're going to find the antiderivative. We're going to be given a differential equation that has both x and y in it, just like this. And then we are going to find the equation that has that derivative. And the way that we do this is by separating the variables. Okay, we have to make it so that all of the x's are on one side and all of the y's are on the other side of the equal sign. So looking at number 1, I have dy over dx equals x squared over y. So what I can do is I can multiply both sides by y. So that gives me dy dx equals x squared. And now what we can actually do is multiply both sides by dx. And then I have y dy equals x squared dx. And we have made it so that all my y's are on one side and all my x's are on the other side. Now we can take the integral, find the antiderivative. So we're going to take the integral of both sides. And since this is in terms of y, we're just going to take the antiderivative like we normally would. So antiderivative of y, I'm going to get y squared over 2 plus c. Antiderivative of x squared is x cubed over 3 plus c. Now, these two c's are not necessarily the same c, so we're going to label them as c1 and c2. They might be the same, they might be different, we don't know. It's just some random constant that we don't know the value of. Once we've taken the antiderivative, taken the integral, we are going to solve for y. Put it into an explicit equation. So I am going to subtract c1 from both sides. Okay, so I have some unknown number, some constant, minus some other constant is going to be a third constant that I still don't know the value of. And what happens, guys, is we just write this as C. We don't need to keep labeling these as C1, C2, C3. It's just some other C that we don't know. Okay, now I'm going to go through and I'm going to multiply everything by 2. So that gives me y squared and 2/3 x cubed. And guess what? 2 times some constant is still some constant that we don't know. The C is kind of like this black hole that just, anything you add to it or multiply it by, it's still just going to be some constant C. Last thing now is to take the square root of both sides. And anytime you take the square root, you're going to have plus or minus. And that would be our final answer. Okay, let's try the next one, number 2. First thing I'm going to do is get all my y's on one side, get all my x's on the other side. So I'm going to divide both sides by y squared, and then I'm going to multiply both sides by dx. So I get 1 over y squared dy equals sine x dx. Okay, now I'm going to take the integral of both sides. And remember, 1 over y squared is really y to the negative 2. So when I do the integral, I'm going to increase the exponent by 1, divide by the new exponent. The integral of sine is negative cosine plus c. And guys, pretty much, in after this one, I'm not going to write a plus c here. I'm just going to write the plus c over here because what's our very next move to solve for y? It's to subtract c. And you're just going to end up with some constant on the right side. So we just have a plus c, some number on the right side. Okay, now I'm going to multiply everything by negative 1. Y to the negative 1 is the same thing as 1 over y. I'm going to have positive cosine x. And guess what? If I multiply c by negative 1, it's still just c. Okay, last step is to get y by itself. 1 over y equals cosine x plus c, which means y equals 1 over cosine x plus c. Okay, next one, number 3. First things first, we're going to get all the y's on the left and all the x's on the right. So I'm going to have 1 over y dy equals x dx. I'm going to take the integral, both sides. Integral of 1 over y is going to be natural log of y. And that's going to give me x squared over 2 plus c. Okay, now our algebra. To undo taking the natural log of something, you have to e both sides. Okay, e to the natural log of something is just that something. They're going to cancel each other out. So you're just going to be left with y equals e to the x squared over 2 plus c. Okay, now, if this were like a multiple choice question, the answer option would not look like this. And let me explain why. So over here on the right, or the left, directions. Okay, if I have x squared times x cubed, that's x to the 5th. Or in other words, x to the m times x to the n is x to the m plus n. Well, that's exactly what I have right here. I have a power of a sum in my exponent, right? One thing plus another thing. So what we can actually write this as is e to the x squared over 2 times e to the c. Because when we multiply powers with the same base, we add the exponents. And e to some constant is just some constant. So the way that we would actually see our answer is as c times e to the x squared over 2. Okay, one more example. So for this one, what you're going to have to do is factor. What do these terms have in common? These terms have a 2x in common. And if I take 2x out of both terms, I'm going to have y plus 2. And now I can divide both sides by y plus 2, which is going to give me 1 over y plus 2 dy equals 2x dx. All right, I'm going to have you pause the video and see if you can solve for y, or take the integral. All right, we're going to take the integral. So find the integral, solve for y, and then when you're done, check back, see how you did. All right, here is the answer that I got. Check over your work, see how you did. Pause it if you need to, check over the steps. No homework problems to do going along with this lesson. We'll go over any of your questions next time I see you.